Hello everyone. This topic is sheet metal working, that is unit number 3 second part. Here we'll be discussing a sheet metal operation. So first question may arise, where to call which operation is sheet metal or machining. So the basic is I can call it the sheet metal only when the thickness is very small and that value is 6 or 8 mm. So when thickness is less than 6 mm, I can call the particular operation is sheet metal operation. So it is acts as a small thin sheets. Greater than 6 or 8 mm thickness, it acts as a workpiece or it is acts as a plate. So it comes into the category of machining process. So sheet metal working involves two types of operation. First one as cutting operation and the second one is forming operations. In case of cutting operation, we cut the sheet metal, means we remove some part from the sheet metal, as it is named cutting. In forming operation, we are not cutting or removing any part from sheet metal. There will be a slight change in the shape or the formations of this metal sheet. Hence the name forming operation. That's the basic difference of cutting and forming operation. In exam, the questions are draw a sheet metal cutting operation. So you should draw a diagram or operation where we actually cut the metals, or forming operations where we need to have only the change in the shape and the size of metal sheets. As third point, very important, sheet metal parts are generally classified or characterized by high strength, good dimensional accuracy and surface finish. A very good example is in day-to-day life we see a lot of sheet metal operations. That is a computer CPU cabinet. It is also a sheet metal operations. Similarly, we have sheet metal roofs, which may be made up of plastics or it may be a steels. So material doesn't matter, applications and the operations are same. In case of sheet metal operations, the machine used is called as a press, and the tool which perform the sheet metal operations are called as punch and dies. So again it is classified cutting, bending and drawing, where we can say the bending and the drawings are the types of forming, or it is the part of forming. Next part, a one schematic 3D diagram is shown here and one actual image, that is for sheet metal working operation, that is press, to understand how the sheet metal operations are done. Again, general example, I have taken this image, that is a CPU cabinet, which is you might have seen. Most of you are aware of this different shapes. So actually in this lecture we'll be dealing with a different operations which is performed under the sheet metal cutting and forming. So general advantage of this sheet metal working are they are light in weight and low cost. Production rate is extremely large, that is high. The dimensional accuracy and the surface finish both are good in this, and for this we does not require any skilled labor. So these are few general advantage of sheet metal operations, and limitations are very general. As we know, in the first title we discuss if the thickness is low, then only we can call a sheet metal operation. So accordingly the strength of components comparatively low than forging operations. So we'll be dealing with now in detail different applications of sheet metal working process. So applications of sheet metals are very general in day-to-day life. That you might have seen this steel basin forming operations. It is again metal forming. This car body thickness of this sheet is also less than 6 to 8 mm. So I can say it is a operation sheet metal working. So all body parts of automobile, this again this small automobile equipments, They are also made up of under sheet metal operation because the thickness is very small. So automobile, truck body parts, aeroplane parts, construction farm equipment where we use this. So that is a sheet metal working application. Now we'll discuss one by one all these operations in detail. First, as cutting operation, as we discussed, in case of cutting, we are cutting some part by using sharp cutting tool or edges. So hence the cutting operation, which can be again represented as shearing operation. Second is bending and third one is a drawing. Bendings are the different types we'll discuss according to the die shapes, and the drawing operation to form a different shapes again with the help of die cavity. So the first cutting operation where we cut the metal, and the second is forming operation where we reform the shape. So bending and drawing you can be considered as forming. So cutting operations where the cutting of sheet metal takes place with the help of sharp cutting edges of course here we have a punch and die. So punch is a sharp cutting edge movable part. So this I can say a punch which is having this sharp edge cutting edge which cuts this sheet metal. So that's a die which are stationary, punch is movable. Because of this sharp cutting edge, the sheet metal cutting operation can be done. So with the different diagram, flow diagram, it is explained a simple cutting operation which can be called as a shearing also. So here simple cutting is explained with the help of a sharp edge of punch. So now we'll discuss next operation, shearing, as similar to the cutting. Shearing operation is a sheet metal cutting first where along the straight line between the two cutting edges. So here you can observe this is shearing punch and having a sharp cutting edge, uh, and against this stationary die, this is fixed die, this punch is cutting these sheets. So that's I can say the cutting operation or shearing operation. Between the two cutting edges along the straight line it is cutting this sheet metal. Hence that is shearing operation. It is these shearing operations are used to cut the large sheets into smaller sections. So when we have a very large sheets and we want to cut into small parts, that operation is called as shearing operation. Like a basic understanding of word shearing, that they are shearing the sheets in the different sections. Upper blade is often inclined to reduce the required cutting force. Here you can observe this. This blade is normally inclined so that to reduce the cutting force. Next, very important, we are discussing now different sheet metal operations. First, blanking and punching. So it is similar to a general to remember to understand the difference between blanking and punching. I'll give you one good example of punching. We normally punch our write-ups where we say it is a sheet metal basically. Let us assume that write-up is made up of a thin metal sheets and you are doing punching operation. So in that what we do, we punch the write-up from a circular cross-section hole. That circular cross-section hole is a west part from the sheet metal. So punching is the operation where we cut a circular hole from the metal sheet, and metal sheet is a desired part and the part which is cut from the metal sheet is a scrap or waste part. Then second is completely reverse to that, that is blanking. In case of blanking, blanking is the operation is to cut the required blank. So from a sheet metal, if any part is cut which is a desired part, then it's called as a blanking operation. So normally we see the gear blank, so or maybe any other blank. Shape may be anything, it may be square, it may be circle. The required part is the part which is cut from the metal sheet. Hence it is called as a blanking operation, which is opposite to the punching. Now next one is one more operation that is called as a piercing. In case of piercing again, it is slightly similar to the punching. Punching, we cut a circular cross-section hole from the sheet metal as a waste part, whereas piercing is an operation where any any shape, regular, irregular shape, can be cut from the sheet metal, and the desired part is a metal sheet. The difference is, for piercing shape is anything, but for punching it should be circle. Next operations are as forming category: blanking, punching, piercing or shearing. All these are metal cutting operation, whereas bending is metal forming operation, where we are reforming the shapes. So very general word, bending. The sheet metals are bends as per desired or required parameters. With this diagram it is explained. A neutral axis is the axis along the center of the sheet metal thickness, that is because the neutral axis plane. So at the bend section, on the inner side, the fibers are compressed, so you can observe their compressed position. So inner fibers, whereas outer fibers, they are stretched when we are doing the bending operation. So at fiber level or at neutral axis, compare with neutral axis, when bending operation takes place, inner fibers are subjected to compressive load, whereas outer fibers, metals, are stretched. In case of bending, the spring back effect takes place. What it means, when in a punch and die, when we want to have a V shape, let us say 40-degree angle for the V shape, when we remove the punch, because of elastic energy recovered by material, it slightly again bend, and that gives the unnecessary increased angle of bending, let's say V bending for the material, and that elastic recovery is called as a spring back. So accordingly, to avoid the spring back, we may have a slightly lesser angle for the punch and die by considering this effect called as a spring back effect. In case of V, again they are sub-classified as V bending, edge bending. As name suggests, when the punch and dies are having V shape, it is called as a V bending. Edge bending, along the edge, if the metal sheets are bent, it may be called as straight bending. That is called as edge bending. Remember here, for edge bending, we need to have pressure pad as a supporting member, so that along any one edge of the die we can bend the sheet metals. Next operations, they all are edge bending operations, I explained. This basically edge bendings. The third type in the category of forming operation, that is drawing. So formation of a cup from a sheet metal is called as a drawing operation, or drawing a box or a curve shapes, it's called as a drawing operations. So from this figure you can understand, a simple circular metal sheet is converted into the simple long deep cup kind of shape, or a box kind of shape, that is formed by using a different punch and die. Along with this we have a blank holders. So the additional important this diagram is for sheet metal operations, where we have these two dies, that we can say a die which are stationary part, and this blue color is a metal sheet, thin section. To form the metal sheets of U shape, this cup here has this shape, supporting pressure pads are required, that is called as the blank holders. To hold this blank, we required this force to place this metal sheet in a respective position, that is called as blank holder. So to form a drawing operation, to form this U-tube or a cup shaped cavity from a sheet metal, we required blank holders. Now next, this is a very general applications of drawing operation. Beverage cans are manufactures a small aluminum sheets can be made. With the help of aluminum sheets we can form this kind of shapes, which may have an enormous application in food industry also. Next is a forming operation. As we discussed, all this automobile parts, body structures can be manufactured in a forming operations. They are normally used forming operation in automobile aircraft parts as well as in a steel furnitures, toys and jewelry. These are general applications of forming operation where we need to form the different shapes by application of heavy compressive force. Next one is a different sheet metal operations. First, as here you can see, a lancing operation. A lancing operation is operation where we cut the some part of metal sheet, and if the same part is bent, so I can say a cutting plus bending of a same part is called as a lancing operation. So you can observe these two diagrams. Cutting and bending the same part of metal sheets along any edge or any surface or inside a metal sheet is called as a lancing. You might have seen this operation in CPU cabinet. Next, perforating. Perforating is creating multiple shapes which are equally spaced on metal sheets. The shape need not to be circular, it may be pentagonal, hexagonal or any other shapes, regular or irregular. Perforating is perforating identical multiple shapes in a symmetrical manner. So we are cutting some operation, so it is metal cutting operation, lancing as well as perforating, where we are cutting some part of metal sheets. Next one is notching operation. Notching operations where along the edge cutting some part of metal sheet is called as notching operation. So here we may have any shapes, triangular, rectangular, any shapes along the edge, so that is called as notch, or creating notch along the edge we can call notching operations. So here we can have a complicated blank from this, as mentioned here, from notching operation. Next one is just embossing operation, here mentioned intentionally as it is basically a forming operation. Embossing is nothing but embossing any shape, regular, irregular pattern on the sheet metal. So here we have a punch and die where a desired shape is embossed on a sheet metal, and it's a good example or applications in automobile platforms, or even you might have seen the buses, car trucks floor. They are made up of thin aluminum sheets with small pattern, uniform regular pattern is embossed on that aluminum sheet, which is by using this embossing operations. So with this few diagrams you can understand a different sheet metal cutting and forming operations. This different operations are explained as manufacturing of beverage can. So let us consider the first step is blanking operation, to cut a desired dimension blank for the sheet metal. So let us see here I have a one sheet metal. This sheet metal is of desired size, but out of that sheet metal the required part is this where we are using here. So the desired part is this blank. So this sheet metal is now unwanted part, so operation is blanking. Next, a deep drawing. From this blank we need to, by using this blank holder, we can place this blank here and we can form this U cup kind of shape. So this drawing and redrawing, I combined, like I explained this formation of this cup by using deep drawing operation. Then this curve is again rechanged, increasing its depth to ironing operations. Next steps are this doming operations. Domes are created at this base. So here you can observe again this. Next operation after deep drawing, creating the dome. That's similar to the actually a forming operation. Then again forming the neck, and the last one is a seaming operation. Similar to the edge bending, this last one is seaming to form a final can. All these 7 steps are explained here in the next slide. From a metal sheet to create a blank, then drawing to deep drawing, then along one edge that we call seaming, edge bending. So that's a good example of sheet metal operation to understand a different metal forming operations.